Welcome back to the bench. Today I have an unexpected victim. This is a 940, I believe, and it comes to me by way of a former customer, recommendation by a former customer. And the only thing I know so far is that the VOX engages when it shouldn't. So chances are it's got some electrical issue. I have no idea what's going on here. We will discover this one together, unlike the last unit, where we knew exactly what the problem was. We just didn't know why the problem occurred. Power cord. I didn't need to open that. Okay. So, first thing we're going to do is a good... Oh, these things are heavy. First thing we're going to do is a good visual inspection. I cringe, really cringe, when I watch other repair people, technicians, what have you, who take a device out of the box and the first thing they do is plug it in and push buttons. It's like you're just asking to let the smoke out of the device. Okay, so first thing we notice is the little door doesn't open. Alrighty then. Well, the screws don't appear buggered up, which is always a good sign. Okay. And why doesn't the little door open? Somebody spilled something on here, I think, because it's like glued. There's some sort of... Huh. Yeah, there's something sticky on there. There's like a... Yeah, it's all gooped up. Alright, we'll have to clean that with something later. Looks like grease. Some sort of grease that's dried up on there. There's a... looks like a high-density polyethylene. A high-density polyethylene strip. Right here on the back of the little door piece to help it slide. And it's not made better by lubricant, so I think that's what happened. Somebody put lubricant on there, and it, or maybe Kenwood did. I don't recall seeing that on any other 940s that I've ever opened up. So we got to clean that off. Okay, so a visual inspection. Nothing appears boogered up. I doubt anybody's been in here to change the battery. It looks like the original memory battery is in there. And we check the connections on the power supply, because if those have been pulled off, they usually wiggle a little. They're a little loose. I retighten them before I put them back on, but most people don't. So yeah, I don't think anybody's been poking around in this radio, and that's really a good sign. Power switch feels very funky. And it's apparently just the plastic. But yeah, we'll clean that up too. Let me get a tissue. And now I'm using denatured alcohol here, and make no mistake about it, there's a big difference between denatured alcohol and other more aggressive solvents. And there's a very big difference between denatured alcohol and rubbing alcohol. It's an important distinction. Alcohol is a polar solvent, meaning it's miscible with water. And if you need to clean anything, any type of petroleum distillate or petroleum product, grease, oil, oil-based paint, things like that, you need a non-polar solvent. You need something like mineral spirits or acetone or something along those lines. However, denatured alcohol, because of the fact that it is denatured, contains additives that are in there so that you cannot drink it. So that it has been denatured with stuff. And that stuff is almost always a non-polar solvent. So denatured alcohol has just a little bit of ability, not very aggressive, but a little ability to remove grease and oil and the like. Oh yeah, that feels much better. Cleaned up that little door. It's a silly little thing, but you know, something I didn't want to leave. Okay, and I cleaned up this power switch, which was all goopy. The timer. Okay, now the complaint is VOX operates when it shouldn't. That's the complaint. My visual inspection indicates that it should be safe to power up this radio. So that's what we're going to do. So first thing is I connect a dummy load to the output. Okay, right away that doesn't feel right. So let's look at why that doesn't feel right. I'm going to take off my sleeve. I use the quick connect SOTL259s, and I just want to feel the center pin, and yep, center pin contact is fine. All right, that's good. That's all I want to see. Sometimes it feels a little loose. It could be a little undersized. Sometimes I'll get radios in here, and it's very common with type N connectors on UHF stuff, where the center pin is just wide open. It's just a little, the four little, what would you call it? It's a slotted tube, but the four little petals, if you will, of the center conductor, the center female receptacle on the type end, are just opened up like a spring flower. Oh, gee, the receiver's 50 dB down. I wonder why. There's no connection. All right. And we need electricity, as somebody I know says. I'll put some pixies in the works here. Yeah. Can't find the hole. I can make a joke about that, but you know, I might upset somebody in California. All right. Let's see. Tuner off, send off, Vox off, volume, mic gain all down. Well, I'll give it a little volume. To RF gain all the way up. Receiver controls to center. Notch down, squelch down. Let's see, power. Collector voltage. We'll look at collector voltage since there's nothing else to look at. Power down, mic down. AGC fast. Attenuation 20 dB. I like attenuation. You never know. And we're ready to power up. It makes noise. Okay. Yay. That's right. The Vox activates when it shouldn't. Yay. 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 That's a problem. Yay. Yay. Now, I am very hesitant to say, this should be an easy fix. No. Not likely. Yay. 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 I fixed it. Okay. Bye. Oh. All right. So, obviously, problems in the switch. Yay. 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 Did I fix it? No. No. I'm still getting a on the air light. So hit. Yep. So what's happening is there's no delay. Hey. There's no delay. When the switch is out, it still keys in Vox, but there's no delay at all. Yay, yay. Turn the gain up. Yay, 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 yay. The gain works. I would think it would have to. Yay, yay. But it bypasses, it seems to bypass the delay, because if I turn the Vox on, yay, yay, yay. Delay. Delay. Delay up. Delay 5. Delay 10. Delay 0. 0. 0. Okay, box off. Delay 10. Yay. 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 Okay, delays at 10, there's no delay. Alright, so that gives us a little clue. So let's go, now it's time to look at the schematic. And try to decipher things. What was it the sports announcers used to say? Let's go to the videotape. Well, here we are at the infamous PDF service manual, which I both love and hate. Anyway, this is kind of it's kind of circular logic here, and where do you start? It's like examining a feedback system. You know, it's a feedback system. It's a loop. Where do you at what point do you break the loop and start? And I guess it's a matter of where you're comfortable with. You could start with the schematic here of the VOX circuit, or we could go to the overall view of the wiring diagram for the whole radio and all the boards in it. I'm comfortable starting here with the VOX circuit. So we're going to blow this up. And I can see that the VOX circuit is up in this corner. We have our VOX gain pot feeds from the switchboard on top of the radio. That's switch F. Switchboard F feeds audio into here, goes through some gain stages, and I guess they're using one of these transistors as just being used as a detector, because it's going right into a gate. They're also gating that with what looks like VOX, anti-VOX. I think that's anti-VOX. Anyway, it doesn't really matter. We'll find that out later. But it suffice to say that with the VOX switch off, we're getting triggering in here. So obviously this is detecting VOX audio. So we're getting triggering of this gate when we shouldn't be. However, the VOX delay, which is switched, well, the actual delay value comes in from a potentiometer here, and that potentiometer controls the decay rate of this filter. So that's the delay rate. This whole circuit's not working, or it's not charging, or it's not being enabled, or something along those lines is not occurring, because we're not getting a delay when the VOX trips in the off position. In the on position, it seems to work fine. And if we come down here, here we have our VOX switch. This is actually the VS1, VS2. This actually comes from the VOX switch, which is ostensibly giving us the problem. And if we follow these two lines in, we come up to a gate here. We also come to the input of a circuit here. That kind of looks like that combines with the output of the delay. And the VS1 here, where does that go? VS1 gates here. Okay, so obviously VS1 is remaining enabled because we are gating. So that doesn't really tell us any more information than that. I don't believe there's any problem in this, but it does give us a little bit of an idea that we've got two things coming in from the VOX switch. One looks like it's maybe the delay gating, and the other one is the actual input gating over here. So enough of that nonsense. Let's move on. Let's find out where these signals are coming from. So let me jump back here just once more. Switch F and switchboard A. These are the two switchboards from which all of our input signals come. That's pretty much what we need to know there. So let's jump over to here, and we're going to look at switchboard F, which is on the top of the radio. We don't believe there's any problems with that. We have no reason to believe there's any problems with that. Anti-VOX delay. VOX gain. Where's the anti-VOX? Oh, that's anti-VOX. Yes, VOX. Yeah, anti-VOX and VOX gain. Okay, so they work together, and that's yeah, VXC and FG. Yeah, I guess that's VXC. Yeah, G for gain. This is audio and delay. Okay. The other input comes from switchboard A, which is over here. And if we look at A, we see the VOX switch. Now remember, there was two VOX. There was a VS1 and VS2. And VS1 we were suspecting of not disabling. And I believe VS2 went on to the delay circuit. And VS2 gets switched to this circuit, and this is the full part of the full semi circuit. This is CWB plus, so that's obviously that's not active. This probably is only active in the CW mode, VS2. So we don't really need to concern ourselves too much with that. So we're back to VS1. This is probably our problem. It's not deactivating. And VS1 goes to IF port MA. I don't know what that's all about. Huh. Interesting. And in the off position, which is the position that's actually not working, it's grounded. It goes to ground. Now it shows ground as just ground. It's just a circuit point. All grounds here are common, and then there is one. It goes out on a control wire here to ground. So there's only one ground. Now I'm mentioning this to you particularly because I already know what's wrong with this radio, and I'm going to tell you now. If I go up a page, we're going to go take a look at switchboard A. We're actually going to look at the circuit board layout for switchboard A. So here, up here, we have the VOX switch, our full semi switch for CW, and we have a pin labeled G for ground, which goes to, if we follow this trace, it goes to this big pad, which has a screw through it into the front panel. And then over here we have another pad which has a big screw through it, which goes to the dimmer switch. Now I'm going to tell you a symptom that I neglected to tell you in the video because I kind of didn't notice it. The meter lights don't work. The meter lights don't work. Huh. So assuming that it's possible that the solder connections on these switches were broken, because it is possible, anything hanging out of the radio, whether it's a switch or a plug on a jack, frequently these things get broken. I mean, if any of you have worked on radios, you've seen speaker jacks broken off their circuit boards. Very common. So in poking around in back of the front panel and moving some wires out of my way, all of a sudden the meter lights blinked. Huh. Cracked board, broken solder joints, loose plugs. So to make a long story short, the bottom line here is these two screws were loose. And the peculiar thing, and this is where service manuals really, again, you can't trust service manuals 100%. The schematic showed you, wrong schematic. The schematic showed you all these grounds being continuous and contiguous. One single ground, everybody's happy, everybody's connected. Now if you look at the meter lights over here, you'll see the meter lights come in on a terminal and go to ground. Huh, that's showing a chassis ground. That's not showing an electrical circuit ground, that's showing a chassis ground, which is decidedly different from this circuit ground. But this circuit ground does not show as going to chassis anywhere. It shows it going out on a wire. But, whoops, going back to our board pictorial, that's obviously not the case. So here's our lamp, powered to our meter lamps, and here's our ground, also to the meter lamps, and it goes to chassis ground, but it doesn't go to the chassis ground associated with the dimmer switch. It goes to the chassis ground associated with the VOX switch. Isn't that interesting? So here's what's happening. This switch, which should be grounded in the off position, is being elevated to whatever this voltage is. This voltage being supplied to the meter lights is not going to ground, so this voltage appears here. So when this is in the off position, instead of being grounded, this is up at 12 volts, keeping the VOX gate. Now we can go back to the schematic. Oh, that was stupid. Alright, I can't go back. Well, I can't go back to my schematic. I'll do this. So obviously, if this is being elevated to 12 volts here, we can't turn that off. There's no way we're turning that off. So there you go. So all I did was tighten those two screws, and as you can well imagine, everything is working fine. So let's go back to the bench and wrap this up. Okay, well, my my apologies for missing audio here. Once again, my wireless microphone batteries have let me down. I'm going to have to find a way to modify these things so that they they give some kind of an alert, some sort of a beep or something when they go out of communication. So there you go. So in this little section of video, I am you'll see I'll be demonstrating what I just described to you as far as the poking of the circuit board and the lights blinking on and off. And yeah, this guy looks very pleased with himself. Hey, I put my finger here and the lights go on and off. Yeah, that's brilliant. But you know, any fix is a good fix if it's properly repaired. So I don't look gift horses in the mouth. So this one worked out well, and I get my microphone working better. Anyway, enough of that. So it turns out that was the problem. The ground wasn't being made, and sure enough, if I power this thing up now, the meter lights and the VOX works correctly. Grab my microphone. And no VOX. Box. And the little door opens up and I can change my delay, and VOX off, no VOX. Okay, so it's all good. And there you go. Now it's interesting to note from the service manual that as much as I do like Kenwood, they really didn't have enough information for my liking. And then The only information that was really valuable was looking at the actual shadow diagram of the circuit traces itself, of the actual PC board, and I immediately saw that a ground trace from a ground trace to the VOX switch, as well as the meter lights, had no apparent path to return to ground, other than a trace on the board with the screw. And well, I showed you the screw, so there you go. Nice repair, quick, simple, easy. It's what I like. I maybe get a repair that easy, once every 10 years or so, but I'll take it gladly. So that's it for this 940. Thanks for watching.